established 4G network, and that's going to support all the kit in the house.
Okay.
So that Keith can go home tonight and he'll see all of the data coming up as real time. But also what it does is it collects the data locally, so if anything drops off or happens during the night, you're covered, you've got the insurance, it will push that data back up once it rejoins onto that router.
Okay.
So the box that he brings in now is almost like a local logging device.
Okay.
So worst case scenario, if the 4G drops out, it'll log locally until that comes back up and then it'll push it back on.
Okay.
But it's all supported by mobile network at this stage in terms of the kit.
Okay.
And that's mainly so we can push the data up to the cloud and speak to the software, as well as make it all automated so we can turn things on and off via the dashboard rather than being on site. So that's the local data logger, so that will have all of the stuff on. You don't need to use it unless you've had an issue basically with the Wi-Fi. So it's purely an insurance tool. Because what's happened in the past is that, just pop it in there, that's it. What's happened in the past is we come back, the broadband's dropped off or the Wi-Fi's dropped out and then data's lost. So that will be there.
Like a bank.
That's a bank, store it there, and then worst case you come back, the Wi-Fi's played up, you've got it locally so you can push that onto the platform, very worst. But we probably only used that once in the last 2.5 years.
Right. Okay.
So it's just a safety, you know. It's not like an airtightness where you can just put the blower door back in. You know, you don't want to extend it by another day. You know, so that's the reason behind that. So the first thing you do is you establish a network locally so that all of your kit can start to be deployed and join on. So I won't put too much pressure on Keith for this time around, but it's pretty straightforward. And then if we're going out here, I can talk you through the other bits and pieces really. So these are basically data loggers that are going to read temperature inside and outside a property. Okay. Each one of these loggers are labelled by room, so you can start to understand heat loss in different areas of the house. So a bit like you've done after your airtightness test, you can start to pick apart the data by room and think, you know, is the bathroom underperforming quite considerably in comparison to somewhere else, which allows you to tie that in with other things that you're doing. Okay. Once all of these are deployed to each room, and then they are logging every minute temperature readings.
Where do they sit? They just sit on the windowsill?
No, so these are on, so they will be in here, these are on freestanding tripods. Okay. So you've got two probes here, and one goes high level, one goes low level, because obviously there's a bit of disparity in heat inside the room, so you take two data points. So it's quite simple. These will automatically connect to Keith's dashboard and the network. It's plug and play type stuff. And what I normally do is you normally put one of those in, and then that's that element done. One outside the property, because you've got to measure external temperatures as well. So you're measuring temperature difference between inside and outside.
Is it just temperature it takes, or barometric pressure, or
just temperature, purely temperature. Okay. We did originally start measuring humidity and things like that, but it actually made no difference in the analysis. So it allowed the equipment to be quite a lot cheaper to do the same job. So there's no real benefit in measuring anything else other than temperature for the purposes of thermal performance. Okay. These are connected to the heating and air circulation stuff. So what these do, so you've got a heating symbol on top of that one and a fan on that one.
Right, okay.
Okay, so so it's a smart sensor as such. So what it does is it monitors the power consumption. So how much energy are we putting into this building? But it also allows the system to turn things on and off when it needs to remotely. Okay, so if you imagine you've got this heater in here, it's got to go on when the sun goes down and then go off halfway through the experiment. What we do is we actually plug that into there, and that does all of the hard work for you. That speaks to the platform. And
so this just keep on?
Keep on, and it will turn it all off as you need to and control it. It's got a safety trip out, all of that kind of stuff. Okay. It's too warm. So all of the control element is through these, as well as monitoring the energy drive. So if you imagine what we're doing is we're measuring the building's response to a known controlled heat load.
Yeah.
Yeah, so you put this many kilowatts in the building.
Yeah. It's only takes.
And this is the temperature difference. So how many watts or watts per Kelvin are being lost through that water.
And how quickly.
And how quickly. And then that can be conveyed in different ways. So what's the average U value? How can we compare that number back to SAP? And you can actually start to do this performance gap analysis. So it's quite useful at this stage because, as we said, air tightness is important, but it's not everything when it comes to performance in general. So that's pretty much it, to be honest.
Cool.
The main bit that Keith has learned about is the placement of the equipment in the property. That's probably the hardest part. Everything else is kind of done via the dashboard.
Okay.
So the dashboard does a lot of the legwork for you. So it proposes the start time, end time, it controls the equipment. So all you need to do is ultimately just put the dates in and the design data, and then you're somewhere near.